Okay, you're going to go ahead and pause the video from me talking, and you're going to watch this video. As you watch this video, fill out this chart right here. I gave you a list yesterday on Canvas under yesterday's date, which was the 3rd. You can look up some things we did in class, but this video will go over what we did in class on different electrolytes. So just make sure to watch that and enjoy that video. Okay, so electrolytes, they dissolve to make a solution that conducts electricity. If you'll notice on the examples down here, just trying to get my pen to work. There we go. Okay, on the examples, ethanol right here, the formula is C3H8O. And what happens is this doesn't break up into ions, and so they stay as molecules in the solution. So because of that, it's not going to create any electricity. You need to remember that you have to have two things for electricity. You have to have positive and negative ions, charges, and you have to have mobility. And the mobility comes from the fact that you're dissolving it into water as a liquid, in a liquid state. Okay, on this one, KCl will break apart into ions. So it'll break apart into potassium ions and chloride ions. And because it does this, and all that we have are ions in the solution, this has a very strong light. And this last one, notice how the light bulb is a little bit less intense than the middle light bulb. This is because we're dealing with acetic acid. Acetic acid is commonly known as vinegar. And here's the formula. This is a covalent compound, but it's polar, which means that the hydrogen ion will break apart. I don't know what just happened.
Courtney Bishop, can you please come to the office? Courtney Bishop, please come to the main office.
The hydrogen ion will break apart into hydrogen and acetate. So on this one, some of the molecules stay together. This would be your hydrogen acetate, which is acetic acid. And some of them, they break apart into ions. So because they don't have as many ions in the solution as, let's say, this KCl, it's going to have a lower light intensity than the KCl. All right. Okay, these are some examples of electrolytes. So under where it says electrolytes on your chart, go ahead and write down the following. Write down ionic compounds, which include a metal and a nonmetal. And then also write down highly polar compounds, which means you have nonmetals, but they're going to break apart into charges. And then, of course, we have acids. An acid is going to be a hydrogen ion plus a nonmetal, and that nonmetal can either come from the periodic table or it can come from the polyatomic ion sheet. Here's a lovely picture of salt. When it is dissolved into water, you're going to get an electrolyte. Okay, so we've already kind of talked about this. Ionic and polar compounds break up into ions when placed in an aqueous solution, and when it does that, it's going to create that light. So here's just like a little funny little cartoon you can read. Okay, so on here, the Na is the blue. So I'm going to write Na right there. And sodium's in group 1, so it has a +1 charge. The Cl is the green. This is the chlorine. And the chloride has a negative charge. So what you're seeing here is that you're seeing the sodium and the chlorine being broken apart, and that's due to the water. So if you notice on here, this water, the oxygen is the red. And oxygen has a negative charge. And so it's pulling away that sodium because it's attracted to the positive charge of the sodium. Over here, notice how you have the white atoms, and the white atoms are representing a hydrogen. Hydrogen has a plus charge, and so that hydrogen is going to pull away the negative atom in this scenario. So this is why water is so good at dissolving and dissolving different substances and turning them into ions, because it has that oxygen's going to be attracted to the positive charge and the hydrogen is going to be attracted to the negative charge in any substance, which is pretty cool. Water is an amazing thing. Okay, a non-electrolyte are compounds that dissolve in water, but they do not form ions. Okay, do not form ions, and so therefore they do not conduct electricity. So under your non-electrolyte category on your chart, go ahead and write down these words: covalent compounds. Covalent compounds are 2 or more nonmetals. Okay, that's what you're dealing with, are nonmetals in a covalent compound. Just like sugar, that's why sugar did not light up. If it did light up at all, it was just because of the water, but sugar is a non-electrolyte because it's covalently bonded. Okay, so let's review the 3 types of bonds that hold atoms together. Pause and take a moment to think about this. We covered this in Chem A, and then we'll come back. Okay, welcome back. So on this one type is metallic. A metallic bond is just made up of metals, metal atoms. Okay, we're not going to use those when we're talking about electrolytes, because if you've ever put a piece of metal in water, does it dissolve, or does it usually sink and it's just a chunk in the water? Okay, another one is covalent. Covalent bonds are made up of 2 or more nonmetals. So remember, within a covalent, you've got polar and nonpolar. They both share electrons, but polar does not share the electrons equally, and the nonpolar shares those electrons equally. And the last one is ionic, and this one is when we have a metal plus a nonmetal. Oopsie, can't spell. Okay, so those are the type of atoms that we're talking about, are metals and nonmetals. Okay, so now let's just review the periodic table really quickly. So in your packet, go to your periodic table and let's just outline things. You may feel more confident about this than other people, but I just want to make sure we're feeling okay about where things are located. So right here, I'm going to draw this line. I think you should do the same. I'm going to erase that one, sorry. Okay, so right here, okay, this is the stair-step line. And what this shows is I'm going to erase that one a little bit. This shows let me redraw that again. Okay, these right here show the metalloids. So right here, these are the metalloids. Metalloids have properties of both a metal and a nonmetal. So it depends on where they're located in the formula. If the ending is IDE, that means it's a nonmetal. So instead of saying tellurium, if we said telluride and it was the second element, then that means it's acting more like a nonmetal. If it's the first element, and like for example, it says antimony with like a Roman numeral 4, that means that it's a metal because of the way that it's written. So those are little hints, but we don't worry too much about that one. Okay, anything to the left of these metalloids are metals, with the exception of hydrogen. So all of these that I'm outlining in this blue color, okay, all of these are considered to be metals, even this bottom box right here. Okay, so these are your metals. And metals like to lose electrons, so they have a positive charge. Okay. Then to the right, we have got our nonmetals to the right of this metalloid line. So right here, all the way down, and it follows that outline of our stairwell. These are your nonmetals. Okay. Nonmetals like to gain electrons, so they're going to have a negative charge. And don't forget that hydrogen is a nonmetal as well. So you might want to just outline this or shade it in, and then make a legend, or else write metals, metalloids, and nonmetals, just to remember where things are. Okay, now also let's go through charges. So remember, charges come from the fact that we need to either gain or lose electrons in order to be more stable. So metals want to lose because it's easier, it takes less energy to lose electrons to be like their noble gases. Okay, so group 1 wants to lose 1 electron, so it has a +1 charge. Group 2 is a +2 charge. Hopefully this all is coming back to you. Group 13 for the most part is a +3 charge. Group 14, it varies, so we're not going to put anything there. And then starting with group 15, we've got these nonmetals. Nonmetals gain electrons to be like their noble gas. So group 15 is a -3, 16 is a -1, and 16 is a -2. Group 17 is a -1. And of course, the noble gases don't have a charge. They're 0. Okay, so hopefully you remember this. Refer back to this if you do forget things. Okay. Now, let's go to this term. So this term is right underneath your chart, and it says, what is dissociation? Ionization. All these terms mean is that we are separating a compound into ions, which is why it's important to remember which groups make which charges. Okay, and down here you see water, and of course water is so good at dissolving, so it's pulling apart the positive and the negative ions. So go ahead and write down that definition. Okay, sodium chloride is an example of an ionic compound. It's going to break apart into sodium chloride ions. Those charges are coming from where they are on the periodic table. Here's another one, calcium chloride. Again, calcium and chlorine from where they are on the periodic table. Notice that you have a 2 right here, and that is part of the formula, but over here we put a 2 as a coefficient so that we had our chlorines balanced out. Okay, when we're writing ions, we're taking a compound, breaking it into ions, and so we don't need to worry about the Brinkelhoff, aka diatomic molecules, because we're not dealing with molecules. A molecule is 2 or more atoms together. So you're not going to worry about putting that 2 right here. Okay, that's a no-no, because it's an ion, not a molecule. Okay. Now we're going to break these apart, and we're going to talk about how these work. So here's sodium chloride. When we break it apart, we get a sodium ion and a chloride ion. And if you notice, when it's already balanced, so we have 1 sodium, 1 sodium, 1 chlorine, 1 chlorine. So on this side, we're looking at how many moles we have that are produced. So you look at just the coefficients. So there's 1 here, 1 here. So we have a total of 2 moles of ions. And this makes a difference. When we talk about how many moles we have, it makes a difference with freezing point and boiling points, which we'll talk about later on next week. Okay, the next one is calcium chloride. This breaks up into calcium ion plus chloride ions. Here we've got the 2 chloride atoms, so we have to show that here by putting a 2 as a coefficient. So our total here is going to be 1 mole plus 2 moles, so we have a total of 3 moles of ions on this side, which is going to make a bigger difference when we talk about freezing points and boiling points. Okay, so let's do this chart together really quickly. So on this chart, let's break things down. So I'm going to go kind of fast because of time. So on this one, potassium is going to break apart. It's in group 1, so it has a +1 charge. Our chloride breaks apart, and it is a -1 charge because it's in group 17. This is already balanced, so we've got 1 mole, so we have a total of 2 moles. Okay, second one, this is called ammonium chloride. Ammonium right here is a polyatomic ion, so that breaks apart into NH4 with a +1 charge. Chloride again has a -1 charge. There's only 1 mole of this NH4, 1 mole here, 1 atom of chlorine, 1 atom here, so again we have a total of 2. This right here is glucose. Glucose is a covalent compound because the carbon, hydrogen, and oxygen are all nonmetals. This one is a nonpolar, which means that they're sharing their electrons. So this one is going to stay as a glucose molecule. So it doesn't have any ions, so this is 0. Okay, this one would dissolve in the water, but it's not going to break up into ions in the water, which is why sugar is a non-electrolyte in water. Okay, this thing is called ammonium sulfate. So again, if you look at your polyatomic ion sheet, which is at the front of your packet, this is going to break up into ammonium, and sulfate is right here. So then we need to make sure that we're balancing this one. Here, notice we have